Good day everyone. Today let us see another case study sum. Now in this sum, you have to use the concepts of increasing and decreasing function and maxima minima. Let us see the sum now. Raj is playing with a spring by throwing it in the air, which is moving along the function f of x is equal to 3x power 4 minus 4x cube minus 12x squared plus 5, and this is the figure given. Now you have to answer the questions. Let us see the first subdivision. Find the critical points of x when it touches the x-axis. You all know what are critical points. That is, we will equate the first derivative, that is f dash of x or dy by dx is equal to 0, and whatever values you get for x, they are called the critical points. So let us start now. Now this is the working column. So the f of x I will write here, that will be 3x power 4 minus 4x cube minus 12x squared plus 5, right? It's a very simple function. So let us find f dash of x. That will be 12x cube minus 12x squared minus 24x. Now we have to equate the first derivative to 0. So let us equate the first derivative to 0. Generally, for factorizing any function, take out the common factors. That is the first thing you have to do. So here if you check, you have 12x as common. I can take it. So I will be getting here x squared minus x minus 2, that will be equal to 0, right? So now this I can factorize. So I will be getting 12x into, this is nothing but x minus 2 into x plus 1, that is equal to 0. It's a very simple factorization. So now you are getting three values, that is x is equal to 0, x is equal to 2 or x is equal to minus 1. So now check your subdivisions, 0, minus 1 and 2. So the option B is your correct answer. So when critical points are asked, find the first derivative, equate it to 0 and then find the x values. Okay. The second subdivision. Find the intervals in which the function is strictly increasing. Before working, you should remember what is the definition of strictly increasing. If f dash of x greater than 0, then f of x is strictly increasing. If f dash of x lesser than 0, then f of x is strictly decreasing. Okay, remember this. Now you know your f dash of x is 12x into x plus 1 into x minus 2. Already you have found it. Now for any increasing decreasing sums, you should first find the critical points which you have already found. X can be 0, x can be minus 1 and x can be 2. So now you draw a number line. Now the number line starts from minus infinity and ends in plus infinity. In between you have got the three critical points. Write them in the proper ascending order, minus 1, 0 and 2. If you get three critical points, you will be getting 4 intervals. If you get 2 critical points, you will be getting 3 intervals like that. Okay. So now you have a tabular column like this, as you will do in the increasing decreasing. How you will find intervals, you remember that one. So now in the interval, I will first write it is minus infinity to minus 1. The second interval is minus 1 to 0. The third one is 0 to 2. The fourth one is 2 to infinity. These are the 4 intervals. Now I have to find in each interval what is the sign of f dash of x, whether it is positive or negative. That is, whether it is greater than 0 or lesser than 0. Depending upon that will be the nature of f of x, whether it is strictly increasing or strictly decreasing, right? So now here I can choose any point within this interval. Let me choose f dash of minus 2. Okay, that is minus infinity to minus 1. So I am choosing minus 2. Now you have to check this f dash of x. Just you write the sign. No need of actual calculation. You don't need the value. So here you have 12x. So the x is negative. So you will get a negative. Then coming to this, minus 2 plus 1, so that will be negative. Here also it will be negative. So the product is going to be negative. That means it is lesser than 0. So the function f of x will be strictly decreasing. So I am putting a downward arrow easily to denote. Okay, upward arrow means strictly increasing. Then come to the next interval, minus 1 to 0. So now what I can take is f dash of minus 0.5. So this outer x, that will have a negation. Here this will have a plus sign and this will have a minus sign. So what will be the product now? The product will be positive. So this will be strictly increasing. Come to the third interval, 0 to 2. So we can take now f dash of 1. Okay. So the outer one is positive. Coming to this 1 plus 1, 2, that is also positive. That will be negative. So the product is negative. So it is strictly decreasing. Come to the fourth interval, 2 to infinity. You can take any number. I will take 4. So the outer one is positive. The next is positive. The next is positive. The product is positive. So increasing. So now, which are all now strictly increasing? This one and this one, right? So now I will get minus 1 comma 0 union 2 comma infinity. So that is your subdivision A. So that is the answer you have to take. Do you understand? For any increasing decreasing sum, find f dash of x, equate it to 0. Find the critical points. Draw the number line. Then whatever critical points you have found, you write them in the ascending order properly. Then you have a tabular column like this. So interval, sign of f dash of x and nature of f of x. Then from this we can pick the answer. So we got the A subdivision as the correct answer for the second one. Okay. Third subdivision. Find the intervals in which the function is strictly decreasing. So let us use the same tabular column. From this we can easily pick our answer. Now you know this is strictly decreasing, right? Then the third one, that is also strictly decreasing. So what is the interval? Minus infinity to minus 1, right? Then union 0 comma 2. Now see here, you have got the same answer here, but here is the intersection sign and here is the union sign. Make a note of it. So now only this is correct. That is minus infinity to minus 1, union 0 comma 2 is your answer for the third subdivision. So for the strictly increasing and decreasing, you can use the same tabular column and you can write the answer. Okay. Let us see the next subdivision, fourth one. Find the value of x in which the spring has local maxima. Now here, to find the local maxima or local minima, I have taught you 3 methods. That is without using derivative, using the first derivative test and using the second derivative test. But here we have already found the increasing decreasing, so we have got all the first derivatives and the nature. So use the first derivative test to find either the maxima or the minima. Okay. So what is the first derivative test? I hope you remember. That is when the function changes from the increasing to decreasing, that is from positive derivative to negative, that point is called a local maxima. When it changes from a decreasing to increasing, that is from a negative to positive, that point will be a local minima. Okay, just remember this. So here come to this table. Here if you see, this is decreasing, this is increasing. So from decreasing to increasing, so that will be minima. If you come to the second and third, from increasing to decreasing, do you follow? If you look at the second and third, that is in the interval minus 1 to 0, this is increasing. That means it will go up like this. Then it comes down. So that point will be a local maxima. So what is the common point here? See, 0. So at x is equal to 0, the f of x, that is the spring, will have local maxima. That is how you have to find using the first derivative test. So you should know which to use easily to get. So actually you see this table we are using for 3 subdivisions and we are able to answer it. So now x is equal to 0. So the subdivision D is the correct answer for the 4th subdivision. Do you understand? So the local maxima means, if you look at the curve now, from increasing to decreasing, that is a maxima. Decreasing to increasing, that will be a minima. Remember that. Using that you can do this easily. Last subdivision. What is the maximum height of the spring? If you want to find the maximum value or a minimum value, always remember, once you know the maximum point or minimum point, that is the x value, go to your original function f of x and substitute that x value so that you will be getting the maximum value or the minimum value, whatever is asked. Here, already you have found in the 4th subdivision, at x is equal to 0, the f of x will have a local maxima. So now you want to find the maximum height, that is the maximum value. So you write your f of x now. Your f of x is 3x power 4 minus 4x cube minus 12x squared plus 5. Now you put x is equal to 0. So that will be the maximum height. So 0, 0, 0. So you will get 5. So 5 is the answer. So the C subdivision is the answer. So you should remember what is the maximum point. How do you find that? After the critical points, okay? You will find the critical points. You can find the increasing, decreasing, etc. Whenever it changes from increasing to decreasing, that point is called the maximum point. How will you find the maximum value? Go to the original function f of x, substitute that maximum point, that is the x value there, and find out what is your f of x or y, and that is called the maximum value. Hope you have understood all the subdivisions and the concepts of increasing and decreasing and how to find the local maxima using the first derivative test. Thanks for watching the video. You can subscribe to the channel if you have not already and click the bell icon so that you will get notifications of further videos. Thank you again.